Hello all. In this lecture, I'll be discussing about the conversion of DFA to regular expression using Rijk method. So here R is the regular expression, I is the starting state, J is the final state, and K represents the number of intermediate states. So if we have a language which can be defined by DFA, then we can also define the same using the regular expression. So for each representation of DFA, there is an equivalent regular expression representation. Now, we can find regular expression from the given DFA using Rijk method, which means that we will receive a representation of the regular expression from the DFA using the formula Rijk. Okay, so now if your DFA has n number of states, then K cannot be greater than n, which means that K can be from the range of 0 to 3. Now, so if your DFA has n states, which means that your K can be from 0 to n number of states. Right. Now, we need to find the regular expression from I to J, and we need to consider that 0 to n number of states of K. Right. So for this, we will have basis state and induction state. So basis state is, so this is your expression Rij power K. Right. So when do we call that it is a basis case is when my K is 0. Okay, when my K is 0, which means that there is no intermediate state, then I call it that it is in the basis condition, initial state, when K is equal to 0. So when K is equal to 0, we have two cases. All we have is now Rij power K. So this K is going to be 0, which is the initial condition. Now I have I and J. Now we have two cases in basis condition. One is I is not equal to J. I is a state, J is a different state. That is the meaning of I not equal to J. Now the second case will be I equal to J, which means I and J are both the same states. So first case is I not equal to J. So here I is a different state and J is a different state. Now, if there is no transition between I to J or J to I, then I can say that Rij power 0 is equal to 5, which is empty. If there is a transition from I to J, okay, if there is a transition from I to J with a input symbol A, then I can say that Rij is equal to A. That is the input symbol. Now there is another option where there is a transition happening between I to J through any of these input symbols, which can be A1, A2, A3 or till AK. So when you have a set of symbols using which the transition is happening between I to J. Okay, so these are the three states, three conditions where K is equal to 0 when I is not equal to J. Now Rij is equal to A1 or A2 or any symbol till AK. You should remember that here plus is the union operation. Union means either A1 or A2 or any symbol that is used as the input to transit between I and J. Next is the basis condition. Basis condition is where K is equal to 0, which means there are no intermediate states between I and J. I is the starting state and j is the final state. Now, when I is equal to j, it means that there is only one state. I and j are equal. Now, if there is no transition between I and itself, then you can denote it using empty string, which is epsilon. Next is you have a transition and the transition is using a symbol A. If so, you can represent it using Rij power 0 is equal to epsilon plus A. Next is when you have a set of symbols using which the transition is between I and I itself. So you can represent it using epsilon plus A1 plus A2 till AK. Now this plus means union, which is it can either be empty or it can be A1 or A2 or till AK. Okay, so induction step. Induction step is where your k is greater than or equal to greater than 0, which means that we have minimum of one intermediate state, okay, one or more intermediate state. So here we have two cases. One is the path doesn't go through k, which is Rik power k minus 1. K minus 1 is the previous state of k. The second one is the path goes through the state k at least once. Now, if you say that the path goes through the state k at least once, then I have a start state I. Okay. Now, it is going through a state k. Then I may have any number of state k's. Okay. And finally, I'm reaching a final state j. Okay. So, here start state is I, okay, I, then final state is K in this case. So R I K, okay, R I K power K minus 1, okay, that is this step. Next, I have infinite transition between K and itself. So R K K, okay, R K K power K minus 1, and this can be repeated any number of times. So star. Now this is R K, okay, and J. R K J. This is the starting state, this is the final state. R K J to the power K minus 1. So when you write it together, you write it like this. You write everything together. R I K power K minus 1 into RKK power K minus 1 the whole star and RKJ K minus 1. So when you join the both the cases together, so if the path doesn't go through K, then Rij power K minus 1 plus this expression Rik power K minus 1 into Rkk power K minus 1 the whole star and Rkj power K minus 1. You write it together. So this is the representation of a regular expression when you convert it from a DFA to regular expression. Thank you.